In the world of strategic weapons, few machines are as complex or as powerful as the ballistic missile. Unlike cruise missiles that fly through the atmosphere like jet aircraft, a ballistic missile follows a very different path. It is powered only during the first few minutes of flight. After that, gravity and orbital mechanics take over. In essence, once launched, a ballistic missile behaves like a stone thrown across the sky, except this stone travels at several kilometers per second. Inside, the missile is not a single machine, but a carefully engineered stack of specialized systems. At the very tip lies the payload section, known as the re-entry vehicle. This component houses the warhead and is protected by a heat-resistant shield designed to survive the intense temperatures of atmospheric re-entry. Modern intercontinental missiles may carry multiple re-entry vehicles. These are deployed using a mechanism known as MIRV, multiple independently targetable re-entry vehicles, allowing a single missile to strike several targets. Just beneath the payload sits the guidance section, the brain of the missile. At its core is an inertial measurement unit. Using extremely precise gyroscopes and accelerometers, the system constantly calculates the missile's position, velocity, and trajectory, without relying on external signals such as GPS. Below the guidance systems are structural couplings called interstages. These rings connect the rocket stages together. When a stage finishes burning its fuel, explosive bolts or shaped charges separate it from the missile so the next stage can ignite. The propulsion stages form the heart of the missile's power. Most modern ballistic missiles use solid propellant, a dense chemical mixture that burns rapidly and reliably. Solid fuel allows missiles to launch almost instantly, making them ideal for rapid response systems. Some older or heavy-lift missiles instead use liquid propellants. These require pumps, tanks, and complex plumbing, but offer greater efficiency and control. Launching a missile itself requires enormous engineering. One method is called a hot launch. In this system, the rocket engine ignites while the missile is still inside its silo. To prevent destruction from the intense exhaust, the silo contains flame trenches that redirect heat and gases away from the missile. Another approach is the cold launch system, commonly used in submarines and mobile launchers. Here, a powerful gas generator ejects the missile from its tube first. Only once the missile is safely above the launcher, usually 30 to 50 meters in the air, does the rocket engine ignite. Once airborne, the missile begins its flight sequence. The first stage is known as the boost phase. Over the course of 3 to 5 minutes, the rocket engines accelerate the missile to incredible speeds. When the first stage exhausts its fuel, explosive bolts trigger stage separation. Small retro rockets push the spent stage away to prevent collision, while the next stage ignites. Steering during this phase is achieved through thrust vectoring by tilting the rocket engine nozzle or adjusting the exhaust flow to guide the missile along its trajectory. After the final rocket stage burns out, the missile enters the midcourse phase. Now, traveling through space, the missile releases its post-boost vehicle, often called the bus. Using small thrusters, the bus carefully adjusts its position before deploying each warhead. One by one, the warheads and decoys are released on slightly different paths, allowing them to strike separate targets. Finally comes the terminal phase. As the re-entry vehicle plunges back into Earth's atmosphere, it travels at speeds exceeding Mach 20, over 15,000 miles per hour. At these velocities, friction with the atmosphere generates extreme heat. To survive, the vehicle is coated in ablative materials that gradually burn away, carrying heat with them and protecting the warhead inside. Within seconds, the vehicle descends toward its target. Guidance systems may make final corrections. And then, the mission reaches its conclusion. From launch to impact, the entire journey takes only about 30 minutes. A complex fusion of physics, engineering, and precision technology, the ballistic missile remains one of the most formidable machines ever created. Subscribe for more documentaries on science, engineering, and modern technology, and let us know in the comments what topic we should explore next.